Colorado Precast put on a double T bridge beam load test at their yard with over 200 industry professionals on hand to see a bridge beam failure under extreme weight, or so they thought. The idea of having a full-scale load test came from the Northern Colorado Committee of the Structural Engineers Association of Colorado. The group is a committee of SEAC. Their committee shares webinars with the larger group in Denver on a bi-monthly basis, but they also have field trips on alternate months. The field trip is an educational event for their local members here in Northern Colorado. The idea of the full-scale load test with their members quickly grew to other associations and beyond just Northern Colorado. They needed help if they were going to pull it off, so they approached Colorado Precast Concrete and Colorado Prestressors Association for help to make it happen. Through fundraising partners American Concrete Institute, American Society of Civil Engineers, GCC Cement, National Precast Concrete Association, and Precast Prestress Concrete Institute, as well as Colorado Precast Concrete and Colorado Prestressors Association, they gathered the funds that were needed. With the audience that they were fortunate to have, high school and college students, city, county, and state officials, emergency response personnel, architects, civil and structural engineers, the load test developed a broader meaning than originally intended. To address that, SEAC went to Liberty Commons High School in Fort Collins, Colorado, prior to the day of the event and spoke with the engineering class about building codes, concrete, pre-stressing, and what to expect at the load test. During the event, we pointed out day-to-day loads, building code provisions for design loads, load factors, material safety factors, the ductility of pre-stressed concrete, and the warning signs of a structure overloaded and in duress. They used a pre-stressed double T 10 DT26 designed for a parking structure. StressCon, another good customer of GCC, brought a 50-foot bridge beam in for the demo, a beam built in their Colorado Springs facility using GCC cement. The loading started with four 4,400-pound blocks located similarly to how cars park in a parking structure, with an initial flex of 4.6 inches. One block in each of two parking stalls located at each end of the double T, and 2 blocks at the center of the member to simulate the passing cars in the drive lanes. A 4,400-pound block was used to represent a heavy car. The application of load progressed to 7 blocks representing the building code service load, then 9 blocks for 85% of ultimate strength design. At this point, we measured deflection, removed the 9 blocks, and measured rebound. The 9 blocks were reloaded, and then the loading progressed to 11 blocks for 100% ultimate load and 12 blocks for 110% ultimate load. At this point, 52,800 pounds had been applied, 2 times the service load prescribed, illustrating the factors of safety used in the design of concrete. Flexural cracks were present as expected, but there were no signs of duress. The continued application of blocks now clearly begins to show the ductility of pre-stressed concrete and the warning signs of an overloaded structure. Blocks were added until near failure at 20 blocks or 88,000 pounds. At that point, the total flexing of the bridge was 48 inches, nearly 3 times the prescribed service load. From the audience, the 4 closest contestants guessing the final load received prizes: a laptop, an iPad, a PCI library, and an iPod. After flexing over 4 feet and the beam touching the ground, the weight was unloaded from the beam and the beam rebounded 18 inches, showcasing the lack of a complete failure.